Hi everyone, this is your chemistry teacher Sir Naushad Mehdi, and in today's video we'll be going to solve some of the past paper questions which are related to the topic of the electrolysis. So let's start. This is the first MCQ in which it is saying that what are the products at the electrodes when the dilute sulfuric acid is electrolyzed using the inert electrode. So the electrolyte which is given in the question is the dilute sulfuric acid. So first of all, you must know the formula of sulfuric acid, which is H2SO4. And since it is dilute, it means that it is being dissolved in water. So first of all, you have to list down the ions which would be present in this electrolyte. So from H2SO4, you will be getting two ions, H plus ion and the sulfate ion. And since it is a dilute, it means that it is dissolved in water. So from water you will be getting again two ions, which is H plus and OH minus. So you can see the cations are common, right, from the water and from the sulfuric acid, which is the H plus ion. And from the anion you are getting two separate sulfate ion and the hydroxide ion. Now they are asking about you the products which will be formed at the anode and cathode respectively. So first of all, if we talk about the anode, so you must know that at anode the anions go over there. Anions are attracted towards the anode, and after going at the anode they will do oxidation, loss of electrons, and will be deposited over there. While the cations will go on the cathode and they will be deposited over there by gaining the electrons, which is called reduction. So first of all, if we look at the anode, so anions would be going at the anode. So since we have two anions over here, one is the sulfate ion and one is the hydroxide ion. So when you have multiple cations or anions, so you have to apply the concept of the selective discharge. Only one of the anion out of these two will be getting discharged at the anode, right? So when you will compare the sulfate and the hydroxide ion, so just remember that whenever the sulfate ion is present in the electrolyte, it will never get discharged. Right, sulfate ion always remain in the solution. It will never get discharged because it do not form any stable products. So you're only left with the hydroxide ion. So hydroxide ion will be going at the anode and will be losing the electrons. It will be getting oxidized at the anode to form the stable products over there. So what products will be formed when the hydroxide ion will go at the anode? So you will be getting this equation in which it will be forming the oxygen gas along with the water, H2O, and it would be losing the 4 electrons. So you can see what special product you are getting at the anode, that is the oxygen gas, right? And similarly, if we talk about the cathode, so at the cathode the cations would be going over there, and at the cathode you have one cation only, which is the H plus ion, which is common from both the sulfuric acid and the water. And if the H plus ion will be going at the cathode, so it would be gaining the electrons. So when the H plus ion actually needs one electron, but it would be forming after one electron gain, it would be forming hydrogen, but hydrogen always exists in the diatomic form, so it would be H2. So you would be needing two H plus ions and it would be gaining 2 electrons to form the hydrogen gas. So at the cathode you are getting the product which is the hydrogen gas, and at the anode you are getting the oxygen gas, right? So at anode you are getting oxygen and at the cathode we are getting hydrogen gas. So option B is the correct answer. Now moving on to the next MCQ. In the next question it is saying that which row describes the electrolysis for the molten potassium bromide? Now the molten means that you have melted this ionic compound with its potassium bromide, and once you will ionize it, so it will be in the molten form it will be already be ionized, and you will be getting two ions out of it. One is the potassium ion and the another one is the bromide ion. So no ions of water will be present because it is in the molten form. So only the ions of the electrolyte would be there, K plus and Br minus 1. Now again they are asking what product will be formed at anode and cathode, right? So at cathode the cations would be going over there. So you just have only one cation, which is potassium, right? So potassium would be going at the cathode, and at the cathode it would be gaining one electron, it would be doing reduction, and after reduction it would be forming potassium in the solid state, right? And similarly at the anode, the anion would be going over there. Since you have just one anion, which is bromide ion, so that bromide ion would be losing the electron, right? So it has a charge of -1, so it would be losing one electron to form bromine atom. But you all know that halogen is in the form of diatomic. Bromine is a halogen, right? So it would be in the form of Br2. So you'd be needing 2 bromide ions for that, and it would be losing in total 2 electrons. So at the anode you are getting bromine, right? And at the cathode you are getting potassium. So at cathode we are getting potassium, right? And at the anode we are getting bromine. So option B is the correct answer for this. Now moving on to the next MCQ. The diagram shows the electrolysis of the concentrated hydrochloric acid and the concentrated aqueous sodium chloride using the carbon electrodes. Carbon electrode means that your electrodes are inert electrodes. Inert electrode means those electrodes which do not take part itself in electrolysis, or they do not react with the electrolyte, or they itself are not reacting during the electrolysis process. Now they are asking you at which electrode is hydrogen produced. So there are 4 electrodes given to you, 1, 2, 3 and 4, and you have to identify that at which electrode the hydrogen gas will be produced. So first of all you have to identify the ions. What ions are present in your electrolyte? So in the concentrated hydrochloric acid, you will be having 2 ions of the hydrochloric acid, which is H plus and Cl minus. And since it is concentrated, so it means the water is also present, and from water you will be getting H plus and OH minus. So these 4 ions are present in your first electrolyte. Now in the second electrolyte, it's concentrated aqueous sodium chloride. So concentrated aqueous sodium chloride means that you have, again, concentrated means that it is water is present, right? Aqueous sodium chloride, so in sodium chloride you will be having 2 ions, Na plus and Cl minus, and since it is also aqueous, so you will be having H plus and OH minus also. So again you are having the 4 ions present in this electrolyte also, right? Now if we talk about the first electrolyte, so at which electrode the hydrogen is produced? So for example, if we look at the electrode 1, so you can see it's a positive charge over there. So since this electrode is having a positive charge, so what does it mean? The negative ions would be attracted towards it. Cl negative and OH negative will be attracted at the electrode number 1. So if the chloride ion would be attracted at the electrode number 1, so this chloride ion would be losing the electrons. So after the losing of 2 electrons, it will be forming chlorine gas over there, right? And similarly the OH ion is also present. Okay. So again, if you are having the 2 anions, then first of all again you have to apply the concept of the selective discharge, that out of which chloride or hydroxide ion, which anion will be get discharged. So since it is concentrated, right? So when you have a concentrated solution, so and you need to select that which anion will get discharged. Either the halide ion will get discharged, or with either the hydroxide ion will get discharged. So in this concept you have to see that which ion is present in the greater quantity. For anions, for the selective discharge of anions, and especially for the halide ions, you have to see that which ion is present in the greater quantity. So since this solution is concentrated, so concentrated means that the water is in less quantity. So if the water is in less quantity and your electrolyte is in more quantity, it means that the hydroxide ions which are coming from the water, it would be in lesser amount, and the chloride ions would be in the greater amount. So whatever the anion is in greater amount, that anion will get discharged. So since chloride ion is in greater amount, so that's why at electrode number 1 we are forming the equation for the chloride ion, which is a positive electrode. Okay, so hydroxide ion will not get discharged in this case. Similarly, if you look at the electrode number 2, so since you can see it's a negative charge on that, so it means the cations would be going over there. So you have just one cation. H plus sign. So H plus sign would be going at that electrode, it would be gaining 2 electrons and it would be forming the hydrogen gas. So you can see at the electrode 2 hydrogen gas is being produced, right? Similarly, we have to look for the electrode number 3 also. So in electrode number 3 again we have a positive charge, so anions would be going over there. So again you are having 2 anions, chloride ion and the hydroxide ion. And again this solution is concentrated. Concentrated means that the chloride ion would be in more quantity. And since chloride ion is in more quantity, so chloride ion would be getting discharged at the electrode number 3. And again at the electrode number 3 you would be getting the equation for the chloride ion. So 2 chloride ions would be forming the chlorine gas plus 2 electrons. So again the chlorine is being formed over here, right? And at the electrode number 4, it's a negative charge electrode. So cations would be going over there. So you have 2 cations, sodium cation and the hydrogen cation. Now you have to select that which one will get discharged, right? So in the selective discharge of the cations, when you have more than one cation, 2 different cations are there. So you have to choose any one. So how the cations is being selected, that which one will get discharged. So you have to see the ease of discharge series, right, which is basically the reactivity series, right? So when you will look at the reactivity series of the metals, so you can find the sodium, right, and then when you will go down the reactivity series, so at below you will be getting hydrogen over there. So down the series, the ease of discharge of the ions, increases, right? So whatever the cation is coming at the bottom, it will be get easily discharged, right? It is opposite to the reactivity series. The reactivity series is also the same, but in the reactivity series of metals, as you go down the reactivity series, the reactivity decreases, right? But this is the series for the cations, right? So in the series of the cations, as you go down the series, the ease of discharge increases. So whatever cation is coming at the bottom, it will easily get discharged. And the cation which is above in the series, it will not get discharged, right? So out of sodium and hydrogen, you have to compare that which one is at the bottom. So you can see the hydrogen ion is at the bottom, so it will get discharged and the sodium ion will not get discharged. So it means that at the electrode 4, again the hydrogen ion will get discharged and it would be forming the hydrogen gas. So hydrogen gas is formed at the electrode number 4 also. So at electrode 2 and electrode 4 you are getting the hydrogen gas. That's why the answer is option D. I hope that is clear to everyone. Now coming to the next question. In question number 4 it is saying, what are the electrode products when molten silver iodide is electrolyzed? So in molten silver iodide, since it is a molten electrolyte, right, so you will be having only one cation and one anion. And what would be that cation? The cation would be silver, Ag plus, right, and the anion would be iodide, I minus, right? So at cathode, the cations would be going over there. So this is the cation, silver cation. So at the cathode, the silver will get discharged, right? And at the anode, you just have one anion. So at anode, the anion will get discharged. And since you are only having one anion, and that is iodide ion. So iodide ion will get discharged to form iodine. Okay. So at the cathode, you would be getting silver. And at the anode, you would be getting iodine, right? So option C would be the correct answer for this. Now in the next question, they are saying that the diagram shows the electroplating of a steel object, right? So you can see at the positive electrode, you have the copper, and this copper needs to be plated over this object, which is the steel object. So in the electroplating, just remember one thing, that the metal which you are electroplating, that metal is always at the anode, and the object on the which you are doing the electroplating, right? So in this example, the steel is the object. The object can be spoon, coin, or something like that. So always the object upon which you have to do the electroplating, that object is always taken as cathode. All right. Now Here you can see that it is saying the student made the following statement. The object turns a reddish brown in color, right? The copper sulfate solution changes from pale blue color, and the copper electrode becomes smaller. So you have to see that which of these statement is the correct one. So first of all, if we look at the process, that what reactions are taking place at the anode and cathode. So first of all, if we talk about the anode, so anode is made up of copper right now. So this electrode in this case is your active electrode. Okay, active electrodes are those electrodes which itself take part in a chemical reaction or a electrolysis process. So this copper itself will be taking part in the electrolysis, right? Because it is an active electrode, right? So when this electrode will take part in the electrolysis, so since copper is at present at the anode, right? And just remember one thing, at anode always oxidation will take place. Oxidation always takes place at anode. So what does it mean? It means that this copper itself will be getting oxidized. Oxidized means it will be losing the electrons. So right now this copper is present on the plate, and when this copper is present on the plate, so it has a charge of 0 on it. Okay. Now this copper which is at the anode, right, the copper which is present on the plate, it will get oxidized. So oxidized means it will be losing the electrons. So copper will be losing 2 electrons, right? This copper metal will be losing 2 electrons, and those 2 electrons will be going into the wire, because electrons always travel from the wire, external wire. And when it will lose the 2 electrons, it would be forming the copper ion, and the copper ion will go inside the solution. So this is the copper ion which is coming from the plate, right? Now this copper ion will eventually go to the cathode, right, while the electrons will travel from the wire and it will also reach at the cathode. Now this copper ion will reach at the cathode, and its electron will also reach at the cathode through the wire. And now at the cathode, what will happen? The reduction will take place. This copper ion will again gain its 2 electrons. This copper ion which was coming from the anode, right, by the oxidation from the anode, it will again go at the cathode to gain its 2 electrons again. It will again gain its 2 electrons. So this copper ion will again gain the 2 electrons to form the copper. And now this copper is formed at the cathode, and cathode is made up of steel object. So what will happen? This copper will be deposited on the steel object, right? So this is the phenomena which is taking behind this, right? Now just look at the statement. It is saying the object turns a reddish brown color, right? So on the object is at the cathode, right? So at the cathode, what is happening? The copper is being deposited, and just remember one thing, that the color of the copper solid is the pink color or reddish brown color. Okay, so this statement is the correct statement, because on the steel object the copper is being deposited and the copper is of reddish brown color. So this statement is the correct statement. Now in the second statement is saying the copper sulfate solution changes to a pale blue color. Now just remember one thing, the initial solution was of copper 2 sulfate. So copper 2 sulfate means that originally it is having a copper ion and the sulfate ion. So whenever the copper ions are present in the solution, the color of the solution is blue color. So initially the color of the solution will be blue because of the presence of the copper ion in the electrolyte, right? Now during the reaction, during the electrolysis, what is happening? The copper from the anode, this anode, right, is getting oxidized, is forming the copper ions, and the copper ions which are coming from the anode, their copper ions are only going at the cathode, right? The copper ions which were present inside the electrolyte initially, they are not getting reduced at the cathode, right? The copper ions which were present in the copper 2 sulfate solution, they will remain as it is. Okay, the copper ions which are present in the solution or in the electrolyte, they are not getting reduced at the steel object. they are remain in the solution, while the copper ions which are being deposited at the cathode. So from where these copper ions are coming? These copper ions which are going at the cathode are coming from the anode, right? When the anode, the copper which was present at the anode, right? When it was getting oxidized, it was forming the copper ions, and that copper ions are being again reduced at the cathode. Okay, so the concentration of the copper ions which was initially in the copper sulfate solution, it is not getting changed, right? Initially the copper ions, whatever the copper ions are present in the solution, it is not getting changed, right? So it means that the color of the solution will not gonna change because the concentration of copper ion is not changing. Okay, so it means that this statement is incorrect. Now in the last statement it is saying the copper electrode becomes smaller. Okay, so what is happening at the copper electrode? The copper is getting oxidized, and this copper which is getting oxidized, it is converting into the copper ions. So when the copper electrode in the solid state is converting into copper ions, so this solid will be start vanishing, right? It will be start decreasing its mass because it is converting into the ions, right? So this statement is correct that the copper electrode will become smaller, right? And the mass at the steel object, because since the copper is now depositing at the steel object, so its mass will start increasing, but the mass at the copper anode, right, it will be becoming smaller or decreasing. So statement number 3 is also correct. So 1 and 3, both of these statements are correct, so option C is the correct answer. Okay, now in the next question it is saying that which products are formed at the electrodes when a concentrated solution of sodium chloride is electrolyzed? Now concentrated means that it is also aqueous, right? So what ions would be present? From sodium chloride would be getting Na plus and Cl minus, and from the water you will be getting H plus and OH minus. Okay, so at cathode the cations would be going over there, Na plus and H plus. So out of these two cations you just have to electrolyze or deposit only one of the cations. So you have to again apply the concept of the selective discharge. So now you have to see either the sodium ion will get discharged or either the hydrogen ion will get discharged. So as I have already told you earlier that whenever you have to select the cation, you have to see the reactivity series, the ease of discharge series, right? The cation which will come below, it will get discharged. So when you will look at the reactivity series, the sodium cation is at above and the hydrogen ion is at the bottom, the below. So the cation which is at the bottom position, it will get discharged, and the ion which is present at the top, it will not get discharged. So hydrogen ion will be getting discharged, so it means that the hydrogen gas will be produced at the cathode. So either the answer is option A or option B. Okay, because in option C and D the sodium is given, so it would be the answer. Now look at the anions. Now in the case of anion, you have to check that either your solution is concentrated or dilute, right? So whichever the anion is present in greater quantity, whatever anion is present in the greater quantity, that will get discharged. So you have two anions, chloride ion and the hydroxide ion, and now you can see the solution is concentrated. Concentrated means that the chloride ion will be in more quantity and the OH ion will be in the less quantity, right? So it means the ion which is in the greater quantity will get discharged. So the chloride ion will get discharged. So when the chloride ion will get discharged, you will be getting the chlorine gas out of it. So option A is the correct answer for this. Now in the next MCQ it is saying lead 2 bromide is electrolyzed using the inert electrodes. Which statement is correct? So you have molten lead 2 bromide as your electrolyte. So first of all, identify the cations and anions. Lead 2 means that you have Pb plus 2 as your cation, and bromide means that you have bromide ion Br minus 1, and it is molten, so no need of H plus and OH minus ions, right? So which statement is correct? A brown gas is seen at the positive electrode, right? So first of all, if we make the equations of anode and cathode, so at anode you know that the anion will go at the anode. So it means that anode is a positive electrode, right? So at the positive electrode or at the anode, the bromide ion will be going over there. So two bromide ions would be losing the two electrons to get the bromine gas, Br2. So you can see at anode the bromine gas is being formed. So bromine gas, what is the color of the bromine gas? It is reddish brown. Okay. So here at the anode, the observation would be a reddish brown gas will be formed. Okay. And similarly at the cathode, the cations will be going over there, which would be a negative electrode. The cation, the positive cation will be attracted towards the negative cathode. So cation Pb plus 2 would be gaining the two electrons and it would be doing reduction to form lead over there. Okay. So now look at the statement, which statement is correct. A brown gas is seen at the positive electrode. So you can see at the anode the reddish brown bromine is being formed. So option A is the correct answer again. Okay. Now in the second option we can see the other options also why they are incorrect. Electrons pass through the solution. You all know that the electrons always pass from the wire, the external wire. Okay. They do not pass from the solution. From the solution the ions are passing. So this statement is not correct. Ions pass through the circuit. You all know that the ions pass from the solution. Okay. The ions do not pass from the external wire. From the external wire the electrons are flowing. That's why it is also incorrect. The lead 2 ions are oxidized. You can see the lead ion Pb plus 2 is gaining 2 electrons to form the lead. So it is getting reduced. The reduction is taking place at the cathode. Right, so lead ions are reduced, not oxidized. So that's why it is also incorrect. So option A is the correct answer. Now coming on to the next one. In the next one it is saying dilute sulfuric acid is electrolyte. Right, dilute sulfuric acid. So what ions are present? From the sulfuric acid we'll be getting H plus and sulfate ion. And since it is dilute or aqueous, so we'll be getting H plus and OH minus also. So cations will be getting discharged at the cathode. So at the cathode, the hydrogen ion will get discharged, and the hydrogen ion, if hydrogen ion will get discharged at the cathode, so you'll be getting two hydrogen ions gaining the two electrons to form hydrogen gas. So at the hydrogen gas will be produced at the cathode. Okay. So option C and option D are incorrect. Now if you look at the anode, so at the anode the anion will get discharged. So you have two anions, hydroxide and sulfate. So sulfate ion never gets discharged. So hydroxide ion will get discharged, and when you will discharge the hydroxide ion, so you must remember the equation that you will be getting oxygen gas plus water plus losing 4 electrons. So oxygen gas is produced at the anode. So at the anode you are getting the oxygen gas, right? Now concentration of the acid. So both option A and option B are, the first two columns are same, right? Now you have to see the concentration of an acid. So will the concentration of an acid decrease or increase? Right? So the concentration of an acid, as you can see that at cathode, initially it was the sulfuric acid as an electrolyte, okay? So here is your electrolyte, which was sulfuric acid, which is aqueous sulfuric acid, which was H2SO4. Okay, dilute H2SO4. Now they are asking that what will happen to the concentration of an acid during the electrolysis. Okay, so you can see during the electrolysis at anode and cathode, what is happening? You can see at the anode, one of the product is your water, H2O. Now where this water will go? Obviously the water which is formed at the anode, right? At the anode where the water is being formed. So over here the oxygen is also being formed, but the oxygen will be formed in the bubbles and it will go out of the electrolyte. But where will the water will go? The water which is formed at the anode, that water will become the part of this electrolyte. Okay, because water is formed in the liquid form. So as soon as the water will form at the anode, it will directly go into the electrolyte because it is in the liquid form, and when the water will go into the electrolyte, So the concentration of the amount of the water will get increased. So if the amount of water in the electrolyte will increase, what does it mean? The concentration of the acid will decrease. It will become more and more dilute because the water is being formed at the anode. And when the water is formed at the anode, it will become the part of the electrolyte. And when it will become a part of the electrolyte, it will decrease the concentration of an acid. Right? So option A is the correct answer for this. Now, the next question, it is saying that aluminium can be extracted by the electrolysis of aluminium oxide dissolved in molten chloride. Now this question is related to the extraction of aluminium. Now when you're extracting the aluminium, so you have to use the electrolyte which is your molten aluminium oxide, and in the molten aluminium oxide you have two ions, which is aluminium ion and the oxide ion. So aluminium ion is a cation, so it would be going at the cathode, right? Because it is a cation, so it will be getting discharged at the cathode, and the oxide ion will be discharged at the anode because it is your anion. So at the anode, the oxide ion will get discharged. So oxide ion, what oxide ion would be doing? It has -2. -2 means it will be losing the 2 electrons, right? So when it will lose the 2 electrons, right? So after losing 2 electrons, it will be forming oxygen atom. But oxygen, you know, is in the form of diatomic O2. So 2 oxide ion will be losing the 4 electrons to form the oxygen gas, right? So at anode, this reaction will be taking place, right? 2 oxide ion will be losing 4 electrons to form the oxygen gas. So if you will take the 4 electrons on this side, so it will become the equation like this: 2O2 minus 4 electron gives oxygen gas. So this is the alternate way to write this equation. Either you write in this form or either you write in this form. So here you can see in the table, this is the equation which is at the anode, which is we are getting the similar one. And at the cathode, the aluminium will get discharged, right? So aluminium ion will get discharged at the cathode. So at the cathode, you will be getting the aluminium ion. So aluminium ion, what does it have to do? It has a charge of +3, so it has to gain 3 electrons to form the aluminium, right? So this is the equation at the cathode. So option D is the correct answer for this. Okay. Now the last MCQ, in which it is saying that the molten salts of 4 metals are electrolyzed. So you have salts of 4 different metals. The ions of which metal require the smallest number of electrons for 1 mole of atoms to be liberated during electrolysis. So they are asking that when the ion of that metal, so obviously the ion of the metal is always a cation. You always know that whenever in the electrolyte you have an ion of a metal, so that ion of the metal is always in the form of cation. So they are asking that which metal cation would be gaining the smallest number of electrons. So it means that it will depend upon the charge on it, the charge on the metal. So for this you have to use the periodic table, right? So first of all, look at the periodic table and find where aluminium is. So in the aluminium in the periodic table is in the group 3. So whatever elements are present in the group 3, it means that they have 3 electrons in the last shell. So it means the aluminium ion will be present in the form of Al +3 in the electrolyte. Okay. Similarly, calcium is present in the group 2 of the periodic table. So if it is in the group 2 of the periodic table, right, so it would be having a charge of +2 on it. Okay. Iron is a transition element, and transition elements have a variable oxidation state. So in most of the time, this iron is either in the form of Fe +2 or Fe +3. And sodium is again a group 1 element. So if it is a group 1 element, so it will always be in the form of a cation, which is Na+1. Okay. So let's suppose that these are the different cations and you need to discharge these cations during electrolysis. So these cations will be going at the cathode, and at the cathode they would be gaining the electrons. So they are asking in the question that the ions of which metal require the smallest number of electrons for 1 mole of atoms to be deposited. So if you want to deposit the aluminium ion, Al plus 3, so how many electrons would be required? Since that is a charge of plus 3, so it will be needing 3 electrons to deposit the 1 mole of aluminium. Okay. Similarly for the calcium ion, it has a charge of plus 2 on it. So since calcium has a charge of plus 2, so calcium ion would be needing how many electrons? 2 electrons to deposit 1 mole of calcium. Okay. Similarly, iron 2, iron 3 would be requiring 2 electrons and 3 electrons respectively. And if we talk about the sodium, since it has a charge of just plus 1, so it needs just 1 electron only to gain, and it would be forming 1 mole of sodium. So sodium is the cation which is requiring the smallest amount of electron, that is only 1 electron to deposit its 1 mole of sodium atom. So sodium, option D, is the correct answer. So that's it for today's class, and I hope that you get a better understanding of this topic of electrolysis. So if you have any queries or any questions related to this topic, so feel free to ask in the comment section. So up till meet you in the next video. Up till then, take care and Allah Hafiz.